this is quite short, just about 15 minutes, but I think because there's a student here, so maybe I spend another 10 minutes. I'm not going to talk about this during the conference, but I think it's very important to introduce what is a limestone ecosystem in general. Okay? So we are doing the same thing from Sabah, Sarawak at this moment. We just finished the Peninsular Malaysia one. So this is the outline. So the first two parts is an extra for this talk. In the conference, I'm not going to talk about this because there is an Asian, it's a Asia Conservation conference. And in that conference, there's a symposium specialized in the karst. So most of the people there, they already know all these things. Okay, but for you, maybe I just go through quickly. So first, I will talk about the Malaysian limestone habitat. Okay, why this is so unique. Okay, and the major threat to the limestone habitat in Malaysia. Then after that, the status quo and challenge. Okay, what is lacking now? Okay, where are we now? And then the next one is to use some openly accessed GIS application, which can be used, can help other people to do some management. At the same time, we develop some tools for other people to use. So first thing first, limestone habitat. So I'm pretty sure all of you know limestone hill, right? Batu Kapogan. Okay, some of them have caves, some of them don't have caves. In Sabah, you don't see them quite frequently, but if you go to Peninsular Malaysia, you can see it quite intensive. In Sabah, most of the hills are very small and scattered around. Okay? And it's not just next to the highway. In Peninsula, just next to the highway, it's very easy to go there. So what I show here, the map, the blue color, regardless the light or dark blue color, is a limestone, okay, or karst or whatever, bedrock. So you can see that most of the karst habitat in the world is concentrated in this region. But when you go to the tropic, there are not much karst. Actually, it's not that there's not much because of the limestone hill is made of calcium carbonate because of the high precipitation in the tropical region. And the limestone hill they will dissolve very fast. So this is Malaysia. So you hardly can't see anything, right? But actually there's quite a good limestone habitat in Malaysia. So actually there's a IUCN group working on this one. Okay. So this is how it looks like, the limestone hills. You see from the far, you go near. So they have very distinctive karst feature. It's very different from other rock. You can easily recognize them. But some of them is covered by the vegetation, especially the small one. So sometimes it's very hard to know if you see the hills, you're not very sure it's a limestone or not. But fortunately, because of the deforestation, you can easily identify that. If you see all the areas have been cleared for oil palm, there's small hills that have not been cleared. That means that they are not suitable for oil palm because it's a rock. It's very easy to identify them. Actually, this is a point that I'm going to discuss later. Okay. So this type of the habitat is, the rock itself is a calcium carbonate, so it's very high pH. Okay. and actually this is not the rock itself, actually this is organic materials, okay, have been deposited in the shallow water millions ago. And because of some geological process, it become hardened and hardened, become rock. And then because of the tectonic process, then they uplifted to the surface, okay, in the core region. And all this habitat is quite fragmented. You talk about fragmentation, right, in the forest. Actually, this habitat itself is fragmented in the Malaysia and tropical region. In the subtropical or even further out, those limestone hill is quite large. Actually, it's not fragmented. For example, the whole Greece is a limestone bedrock on the limestone bedrock. So this is most of the limestone hill in Sundaland. So you can see this black color, okay. And even though some of the hills seem very isolated, but they belong to the same bedrock. Okay, so they have different evolutionary history. Some of them have been separated long time ago, never connected with other limestone hills. But some of them actually were connected until a few thousand years ago and just recently bred into many different pieces. And this has a very big implication to the evolution of the fauna in this kind of habitat. So high pH, fragmented, and small size. You cannot see, right? Can you see any limestone hill here? Actually, if you go to Google, you can see, okay, so this is a limestone hill. Very small. This is just 700 meters. So this is limestone hill. This is limestone hill. This is limestone hill. This is limestone hill. And this is oil palm plantation. And there are one more limestone hill here. Yeah, you cannot see, it's okay, no worries. You can go back and download the Google, you can play around with this one. Okay. I will give you the link later. You just Google my name, you should be able to find this. So most of them are very small. So high calcium, fragmented, small, and they always have a very thin vegetation layers. It's unlike the tropical forest, you have very thick vegetation layer. The vegetation layer is very thin, and the habitat is very dry, because they cannot keep the water. The limestone, right? All the water because they don't have the thick soil and the intensive vegetation belt, they cannot keep the water. So the plant there is quite specialized to this kind of the environment. So these are the characteristics for those for the limestone ecosystem. So if you check the WWF or IUCN, so you know about the mangrove is an ecosystem, right? River is an ecosystem. Marine is an ecosystem. Montane forest is an ecosystem. Lowland forest is an ecosystem. Actually, limestone itself is an ecosystem. But no one really cares about this. There are a few reasons. Okay? So these are the unique characteristics, but also make them quite variable and unnoticeable. This kind of the characteristic give the limestone hill some very unique fauna, because it's like an island that's separated. Okay, then each island usually they have a very unique species, and some of the endemic species only can be found on single limestone hills. Okay, just for example, they have few study. Okay, most of them on plant, not much on animal. The only one that we know from the animal is a land snail. So for example, 40 out of 200 land snails that have been surveyed in Malaysia is endemic to, is restricted to limestone habitat. You cannot find anywhere else. So about 10% of the vascular plant species are restricted to limestone hills. Okay, about 12% of the begonia species is endemic to limestone hills. So this is just a short list. We still don't know a lot of the things for limestone hill. But again, because of the thin layers, usually this kind of habitat they do not support high diversity. The diversity is very low, but most of the species are very unique. So this is about the limestone hills. The second one is about the major threat. Of course, most of the limestone habitat or ecosystem in the world face a similar threat. But in Malaysia, you have two threats is very prominent. And all these three threats is related to this unique characteristic. Okay, because this habitat is very isolated. So it's made even though this habitat, one of the limestone hill has been destroyed, and you maybe try to regrow the vegetation, and hopefully the fauna will come back. They will never come back. Yeah, because they are very isolated, just like the island. It's very difficult. And these are very vulnerable because they're very small in size. You can easily wipe the whole hills within a few months, actually. And you wipe out all the biodiversity and the endemic species. And because of the thin and patchy vegetation cover, they have a low biodiversity and lacking of tiger, elephant, okay, and things like that. They do not have a big mammal, only invertebrate. And recently, there are a lot of the new species of the lizard. Lizard? Yeah, described from Peninsular Malaysia. So the threat mainly is the quarrying. So quarrying just remove the rock from the hills. So it's an irreversible destruction. Just imagine if you remove all the rock, there's no way the habitat can come back. If you go to the tropical rainforest, you cut all the tree. Hopefully, and nothing happened after a few million years, maybe the forest will regrow. Of course, it's not to the previous stage, okay, the condition, but at least it can come back. For limestone hill, no way. If you quarry it, that's it, no more. You have to wait a few million years until the tectonic process and put the things up again. Otherwise, yeah. And it's because of the loss of habitat for many endemic species. The second thing is the deforestation around the hills. So it's not about deforestation on the vegetation on top of the hills, because the vegetation there is not very thick and the trees are very small. You cannot support big tree. But the more severe problem that we see now is the clearing of the surrounding area, because limestone itself is very dry. And the surrounding vegetation, the forest, will keep the moisture. If you remove this, it makes the limestone very, very dry. If there's a fire, then we'll wipe out all the forests on the limestone hills. It's happened many times. And also the microclimate will change. It is already very dry. If you remove the vegetation belt around the limestone hill, it will even become more dry. It becomes drier. So I just give you an example. So this is one of the hills in Pahang, Bukit Sagu, near Kuantan. So this is how it looked like in 1960s. And this is how it looked like in 1990s. So before this, we don't have Google Earth. So you just need to buy the satellite image, so that we bought this satellite image. So you can see, so the hill is still intact, but there's a clearing around the hills. Now you see that most of the forest is gone, all the forest is gone, and they start to quiet the hill. This is just 10 years. And this is 3 years. If you now open the Google, this is left. And this is one of the largest hills in Peninsular Malaysia. So this is the hill. You cannot see it, but actually this is a truck. So the big truck they use in the quarry, you can imagine, is very large, right? Not a normal truck that we see on the road, lorry. It's a very big one. It's here, this black dot. So this hill is very, very huge. Okay, there's a quarry company there, belong to YTL. Yeah. So this is a hill, Panchim, Pahang, just about 2 kilometers away from the Bukit Sagu. Have you seen the hill? It was there. Now it's gone. Yeah. Yeah, the signboard is still there. I went there, still can see the signboard. It's gone. Yeah. And this kind of the destruction removes the habitat. 2 years ago, when I did my PhD, I reviewed the Petostoma, this genus. At the same time, I reviewed their distribution, also reviewed their conservation status. And we sent a report to IUCN. Hopefully they can update the conservation status. And for example, this is one of the species, Petostoma restorvestum. Now it's in a critical endangered. Okay. And this hill is still, had been quarry before, but now the quarry has been abandoned, so it's still there. And surrounding is clear, has been clear for the other plantation. But fortunately, we still can find, there's one endemic species of landscape only can be found on this hill. We really survey 100 meters around the radius. For all other hills, you cannot find the same species. The last time that I was there is 2011. I found 3 individuals only, after spending 4 days on the hill just looking around. It's very easy to find them because this species is obligate to limestone hill. They will on the rock surface. If you scan through the whole rock surface, if you cannot find them, then you cannot find them. Even though they die, they will fall to the ground. If you we do collect the soil, we cannot see any shell, empty shell. So that means that the population level is very, very low. It took us quite some time to convince them to put it in critical endangered. Remember the hills that now you don't see it, only see the leg. There's only one species, there's one endemic species only can be found on that particular hills. Yeah. And that species is described in 1950s. Okay, after that they start to quarry, then now it's gone. Now it's extinct. How many animals extinct in Malaysia? No. Even though you say extinct, some mammal extinct, but you're not very sure. For this one, we're 100% sure. Even though the IUCN still took them about half year to review and go back and forth, because they don't really understand the system, When we explain, give them all the data, then they agree to declare this extinct. So this was in news 2 years ago. So this is in 2014. So they are about, in the release, they have a catalog. They have updated the status for about 22,000 species. Only 2 species extinct. A Malaysian snail is one of them. But you never know, you never come across this news, right? Even though it's on the newspaper, because, snail. Yeah. So this is one thing, the quarrying is very, very serious. Okay. The second thing is the clearing of the surrounding. So this is exactly the hill in Sapulut. So this was taken in 2007. I don't know what happened now. We're going to go back in July and see how it looks like. So you can see the whole hills. The hill is there, but because of the clearing, when they clear, they burn, right? At the same time, they burn the limestone vegetation as well. So we didn't go near, but we think that all the snails are gone. Or maybe there's some pocket population, and hopefully in the July we go there, we try to survey again if we can find anything. So these are the major threats. Okay. Then why this is a major, but this is very generic, right? Everyone can talk about this. You don't really need to know limestone hill, you know this thing happened. But actually, what exactly happened in Malaysia? How many hills is endangered? In fact, how many hills in Malaysia, no one's know. No one's know. Then you should not talk about conservation, right? So far there's no holistic conservation management planning for Malaysia limestone ecosystem. Now we don't even know how many limestone hills in Malaysia. Even though I finished this, we don't know exactly how many. Okay, we have a minimum number, but we don't know exactly how many. The characteristic of limestone hill: how many hills are very big, how many hills are very small, how many hills are very isolated, which hill is very isolated, we don't know. How many hills has been quarried? No one knows. The status of the forest around the limestone hill. Yeah. So this is where we come to the idea, actually, before we talk about conservation. Of course, we have been working on limestone, we know it's very critical and dangerous, and snail endangered, ecosystem endangered, but it's no way you can discuss with anyone if without any hard data. So we try to do some very basic things just to map all the hills and quantify all these parameters. It's very simple. So the idea is to use the public access GIS implementation. So the idea is not to make this, not the whole procedure and also the software available for anyone to use. Not just for the specialists. And all the data is open for everyone to use. So first I talk about the data source, GIS analysis and output. So I will go through this quite quick because this is quite technical, but just explain briefly what we did, not in the detail. So data source. So for limestone hills, it's impossible we survey every inch on the ground, right? So what we did actually, we try to check this from the published geological maps. There are a lot of the good geological maps. Old one, not good, no new one. New one is not good. Old ones are very, very good. But unfortunately, those maps are very detailed, but they can only cover a small area. So we managed to check all the publication by the geological department, and then get all the map. I think we checked about 200 publications, and out of those, only 70 is really reliable. And with the maps, we only check with the maps. We don't believe the coordinate. We want to see it on the map. Okay. Then after that, combine all the map. I think we have about 300. Then go through the map one by one, then mark them. Okay. So this is how it looks like, the map. And then second thing that we use is Google Earth. Although in the Google they don't tell you it's a hills, right? But somehow they let us know what happened on the ground. Because this map, we don't really know what happened on the ground. And we can geo-reference it and see, if you see the hills there, we try to check in the Google if you can see the same hills. And thanks to the deforestation, urbanization, it's very easy to find them actually. It's very obvious, you can see the outline. Okay, this is limestone hill. Yeah, the shape fit with the map. Yeah, this is the hills. Yeah. So these are hills. We try to extract all the information of the hill. Then for the buffer zone, the forest status around the hills, we use the forest cover map. They love the map, but we use the Hansen. The Hansen map is not the best one because they do the mapping for the whole world, so it's not very accurate. But I think this is good enough. Yeah. And we develop the protocol, which in the future, if they have a new map, you just change this map, they can rerun the whole analysis again, give you the same result, which I can show you later. So this is how it looks like. So you show the, I think it's a the canopy density or forest density. So the red color is a very low density, the green color is very high density. Okay. So the value is range between 0 to 100. So this is a raster file. Okay. So the next thing after you have all the material, you have to process it before you can run the analysis. Because some of that is not in the same projection and things like that. So first you have the literature, remember just now, you have the Google. Then we need to do the manual work. There's no computer can help it. Verify one by one. It's very painful. Because when we mark the hills, because some of the hills have been mentioned by 10 reference. They use different names. So we catalog all the information in the Google. So now when you click, you can know which reference mentioned this hill, which name that they use. All of them use different names. That's a problem when people publish the record for another or species or fauna record or whatever. They mention the name, but sometimes you don't really know which hill that they mean actually. Yeah, that's a problem. So we try to minimize it. Okay, we verify, cross-check. We also include a few hills that we are very sure we have been there, we have a photo, everything, include here. But it's not much, just 10%, no, 5% of the data. It's the new data. So this is how it looks like. So now when you click on the hill, so what we did actually just mark in the Google. Nothing fancy, just open Google, then just drag, mark. After mark, just key in the reference. Okay. After that, convert into the shapefile. So this is more technical. You need to do it in the GIS software. Okay. After you have the material, Okay, shapefile, you have the layer, then you can start to processing it now. So we could do some spatial analysis. So first we quantify the limestone hills physical parameter, the size and the degree of isolation. After that, we quantify the limestone hills trait parameters in terms of the absence or presence of the quarrying activity and the buffer area forest degradation. So for the size, it's very easy because you have the digital map already. So the software can easily calculate the area for each hills and give you a table. It's very easy. Just a 2-click, that's all. Then degree of the isolation. So it's very hard to quantify the degree of isolation. How isolate a hill? So what we did actually, we try to, so this is a hill. We try to generate some sort of the hotspot map based on these hills. So the bluish, the area, that means this area have more, this area have a high density of the limestone hills. After that, so this is a layer, right? Then after that, we extract the value to each of the limestone hills. So now each of the limestone hills has a value. The highest the value, that means that around that area, they are in the high density, high limestone density area. That means they are not very isolated. So those are have very low value. That means they are very isolated. Okay. After that, we put these two things together. Okay, so this is a size. This is a isolation. Then we can know what is the isolation and the size of a hill within a context. So for example, we know that, okay, most of the hills are not too small, but they are quite isolated. Okay, for example. Or you can click one hill, then it can show you, okay, this hill is this, okay, that means not very important. So when you talk about the conservation, now we don't know which hill you need to conserve. Largest one or smaller one? Okay, the largest or the smaller? Smallest, okay? We don't know, because we cannot simply make a decision. But at some point of the time, when we have enough biodiversity data, we can make such decision. Okay? Isolated one or not too isolated one? Yeah. Yeah. So if you later you want to make decision, you can make a threshold and then see which hill is need to be prioritized for conservation. But this is just exploratory. Okay? At least now we know what's the status of the limestone hills. So the next one is, this one is quite easy. Okay, quantify the trait parameter. Okay, the first one, present and absence of the quarry. We never go to the field. I mean, we went to the field, but it's very hard to see the quarry in the field. Trust me. Even though there's a quarry on the hill, around the hill, you cannot see it. Usually they do it just if this is a road access, this is a hill, they will do it at the back. You cannot see it actually. Yeah. But fortunately, we have the Google, and Google have a very nice data image, so we can identify it. So it's very distinct. You can see the sculpture. So these are quarry. Okay, yes or no? Okay. But some of the quarry maybe have been abandoned, but they're still active. But we do not quantify that one. Okay. And the next thing is the forest degradation at the buffer zone. So buffer zone means the buffer zone around the limestone area. So there have been a lot of suggestions, the size of the buffer zone, but no one really knows exactly what size is suitable. There's no scientific study for this one. But most people say 200 to 250 meters. So that's the reason why we quantify the vegetation around the buffer zone. Okay. So what we did actually, we have the hills shape, right, the polygon, the GIS data. Then we create a buffer on these hills. Then we just subtract it, clip it, then we get the buffer zone. Okay, so after that, we have the buffer zone, right? Then what we can do next is to clip this vegetation layer by using this buffer zone. Then you can get the buffer zone vegetation. Okay, then each of the cell, just like pit cell, right? Each of the pit cell, different color means different status of the forest. Then we can quantify the status of the forest. Yeah. How many percent of the forest are good forest, bad forest? Okay. And this is how it looks like. So this is the forest at the buffer zone. The green color is the forest. This is not forest anymore. Okay, so the percentage of the good forest, bad, intermediate forest. This is a bad forest, good forest. And how the forest in the buffer zone change, increase or decrease over the past 10 years. The green color is the increase. Okay, it's a forest gain. Okay, red color is a forest loss. So we have this for each of the hills. So this is only for one hill. So we need to repeat the analysis for all the 400 over hills. Okay, repeat this over again. So we decided to write a script. No, ask computer to read it for us, not to do it by manually. First we do it manually for the first 10 hills to explore. After that we write a script. So we use the R package. So we use the QGIS to process the data. But for run analysis, we use the R. So what we did actually is just run the script. It's not too long, 230. So what you need to do, what the user need to do is just mark them. If they see there's a hill, you can mark them, or you can remove them if you think this is not reliable. You can change the shape or whatever. After that, open this script in R, put everything in the folder, forest layer, your KML file, the file that you mark, click run, then they will generate all the data that I showed you just now, something like this, for each hill. So automatically they will have produce a JPEG, look like this. Okay? So now we have the data for every hill. Okay? And this is, we just finished the data analysis. So how to use this to improve management? Still a big question. So we need to put it in the database which people can easily access. Easily access, everyone. Yeah. So what you're trying to do is just put this with Google. Okay? The idea is that you go to the hill, I didn't mark the hill, right? When you click on the hill, you get this information. Okay? Every now and then, if there's a new forest cover available, map, or there's a new hills that someone has added, you can just rerun the whole process, they'll give you the same thing. To put them together, just a little bit of scripting, 20 lines, then you get something like this. So you just double click the file, in one file, KMZ, nothing else, just one file. You click this, you get all this information for each hills. Okay, then you give you the reference. Yeah. So this size, we have about 430 something hills with all this information. The size of the file is just 30 megabytes. You can download in your handphone, you can start to use it. Yeah. So it's very useful for me, myself actually. Now I only know I have so many hills, where to go, which one I have survey, which one I have no survey. Yeah. So this is what I'm talking about just now, okay? About the unit system, the threat, and the challenge, and we try to solve some of the basic things. Okay? Now we try to move forward. So we have done all this. You know something already. So the next step. So you can see this is a size distribution of the hills. So this is a size. You can see most of the hills are very, very small. It's even smaller than a football field. And no one has done any work on this whole hill. No one. Of course, you know about Komandong, Mulu, Langkawi, or those large hills. But for small hills, no one really knows. But those hills, they have a lot of endemic species. Yeah. So this is when you zoom out this, you can see about 250 of the 270 of the hills, so they're about 420, have a size smaller than 0.1 square kilometer. It's very, very small. It's very small. And we also have the map, okay, because you cannot talk. When you talk about conservation, talk about with a quality company or politician, you cannot say, for this hill you have this, for second hill you have this. Repeat the same thing for 400 times, right? So what we're trying to do is just like manage the island. So those hills that group really close together, we treat them as a one cluster. So when you talk about the threat, the biodiversity, we talk about the cluster. So now we can cluster them into 22 cluster, main cluster. So some of the cluster is very isolated. The red color one is very isolated one. And with less number of the hills, the green color is the not too isolated with a lot of the hills in that region. Yeah. So the next one is to do more baseline research, which my student is doing now. And also we hope that anyone can use this map and report their biodiversity data by using the coding that we use. Or maybe at least just put a point here and publish this. This is free, you can publish any biodiversity data. This is the only way to put all the things together in an easy way. So more baseline study for biodiversity, geology, economy, and culture. And also, now we try to make this thing open so people can have an awareness. So this is a comic. So this is, I think this is in Igbo. So you can see the hill is very nice, but this is what happened in the back. You only realize it after, when it's too late, actually. Yeah. And most importantly, I think we always heard about the species extinct, habitat gone, but no, you cannot really see it happening. But for this one, you can see it happening. So, okay, so this is a biodiversity data for one of the genus, the Petostoma that I mentioned just now, the endemic land snail. Not only one species, all the species in Peninsular Malaysia, where we have a record. If you click those, you can check of these hills and click this, you can see the image of the specimen, who collected this, when it was collected. And you can see the status of the limestone hills. And you can see the status of the limestone hill at the same time. And literally, you can see the species extinction happening in front of your eyes. Yeah. Also, hopefully, this can be useful for any purpose. Yeah, that's all. Thank you.